Hello guys and welcome back to my channel. Today I'm going to check the SIYI FT24 budget-friendly long-range 2.4 GHz radio system. In the first part of this review, I'm going to go over the features and specs of the radio controller and show you how to use it, and in the second part, I'm going to conduct a range test. First of all, SIYI is a company that you probably never heard of, as they mostly deal with professional UAV products, and this is their first attempt at creating a product which is compatible with racing drones. In terms of packaging, inside the box along with the radio controller, you can find a USB to micro USB cable, and according to your preference, you can get it with or without a radio receiver. The current available options are the FR radio receiver, which supports PWM, PPM and SBUS, and is more intended to be used with bigger drones, and the second option, which features a much slimmer form factor, is the FR mini radio receiver, which supports both PPM and SBUS. Now, by the way, it's worth mentioning that this is probably the first FT24 radio controller that was sent to a reviewer by SIYI, and at the moment of shooting this video, a full user manual is not available. So the information that I can share with you in this video is the one that I got directly from SIYI, and also by exploring the options of the radio controller by myself. In terms of specs, one of the main highlights of this product is the maximum transmission distance, which is according to SIYI 15 km. It can be achieved by integrating a LoRa RF chip, and later in this video, I'm going to measure the output power of the internal transmission module. In addition, as expected from a long-range system, it supports telemetry. Over there are updates for radio receivers. It supports an optional Bluetooth module for broadcasting the telemetry data. On the center, you can find a 2.8-inch color LCD screen, and on its sides, 6 buttons that will enable you to navigate between the different options and set up the radio controller. The radio controller features a built-in speaker and supports multi-languages, which can be expanded using an optional microSD card. The microSD card slot is located on the bottom of the radio controller. Next to it, you can find a micro USB port, which will enable you to use the radio controller with flight simulators, which I'm going to test later in this video. Update the firmware of the radio controller using a dedicated software which is currently available only for Windows, and extracting the telemetry data. On the back of the radio controller, you can find a standard GR module bay, which you can use for external radio transmitters such as TBS Crossfire and FrSky R9. Over here you can find a trainer port and an expansion port that will enable you to add accessories such as a Bluetooth module. You can power the radio controller either by using two 1860 lithium-ion batteries, which are not included, or by using the balance connector of a 2S battery. In order to comply with FCC regulations, the antenna is not removable. The gimbals, which as you probably would expect since this is a budget-friendly radio controller, are not Hall sensor, are using a 3mm thread, and next to them you can find the trim buttons. On the top side of the radio controller, you can find 4 3-position switches and 2 potentiometers. On the top right side you can find switch F, which is a momentary switch, and on the top left, switch E, which is a 3-position switch. Finally, even though as far as I know the radio receivers support 16 channels, the radio controller itself supports only 12 channels, which is still more than enough for controlling racing drones. Now, after this introduction, let's turn on the radio controller and go over the different options. First, in order to turn on or off the radio controller, you need to long press the power button.
Welcome to SIYI Remote Control.
On the main screen, you'll be able to monitor the battery voltage of the radio controller. In case a receiver is bound, you'll be able to monitor the RSSI values and also the telemetry data in case it is enabled. You can monitor the trim values. Pressing the plus and minus buttons are going to enable you to switch between these 3 predefined shortcuts. The first one is the model selection menu, the second one is the channel monitor, and the third one is the endpoints menu. In order to go back, you need to press the escape button, and in order to select an option, press the enter button. Short pressing the menu button is going to take you to the main menu, where you'll be able to set the model, system, receiver, and enter expert settings. Under model settings, you'll be able to monitor the channels, enter model selection, and as far as I can tell, this radio controller supports up to 32 models. Selecting a model is done by pressing the enter button, and then over here you'll be able to either select a model, rename it, export it, reset it, and copy it. Under model type, you'll be able to define the model, and you can either set it to multi-rotors, plain, and mixed models. The next option is setting up the endpoints. Then you can map the channels, reverse them, adjust and set the subtrims, enable and configure trainer mode, set the failsafe, adjust the program mix, set the servo speed, configure the timer, set the fly mode, which is an option which can be useful for using this radio controller, for example with an APM system, adjust the low voltage alert. Finally, you can set the multi-air control function. By default it's turned off, but in case you're going to turn it on, you'll be able to bind up to 3 receivers and control them simultaneously using this radio controller. Currently next to each receiver it shows no link because no receivers are bound, but in case you would like to bind a new receiver, simply select the no link option. Now over here it's going to show linking, and the power button is going to start flashing rapidly, indicating that the transmitter is in binding mode. Under system settings, you'll be able to adjust general settings and also bind a new radio receiver, which shortly I'm going to show you how it's done. You can set the interface and voice language to either English or Chinese, and by the way, out of the box it was set to Chinese, so you can follow my steps in order to change it to English. You can set the throttle to either thumb slide, which means that it's not going to be self-centered, or self-centered. You can set the sticks layout between mode 1, 2, 3 and custom. You can enable and disable the voice option, enable and disable the TX status, set the TX alert, and in case you are going to use lithium-ion cells, probably it's best to set it to about 6.2 volts. And finally, you can also set the RSSI alert. Under display, you can set the screen brightness and choose whether you want to turn it off. Under external port, you can select the function of the micro USB port. You can set it to data link, simulator, and parameter. And in case you're going to use an external Bluetooth option, you can enable this function over here. Next, you can perform a joystick calibration, which is quite intuitive. You can calibrate the 2 knobs, import and export the settings, perform an ESC calibration, and use a custom voice option, which is going to be available in case you're going to use a micro SD card with the supported data. Next, under the receiver option, under general settings, you'll be able to set the signal of the receiver, which will require you to bind a radio receiver, set the RC delay. Under advanced settings, you can adjust the baud rate, you can monitor the link information, perform a voltage calibration, and finally adjust the 9 available PWM channels. Under expert settings, you'll be able to adjust the Bluetooth settings and enable and disable the external module. By default, this option is turned off, but in case you're going to use an external module using the expansion GR module bay, you can set this option to PPM, SBUS, and R9M, which is the only option which will enable you to configure it. Under R9M options, you'll be able to set the transmission mode to EU and FCC, set the channel range, set the number of receiver, bind it, perform a range test, monitor the RSSI, set the RF power, and configure the failsafe mode. As I mentioned before, currently the SIYI system supports 2 types of receivers. The bigger one, which is intended to be used with UAVs and RC airplanes, weighs 22.9 grams, and the smaller option weighs 3.1 grams. While the bigger radio receiver features a dedicated bind button, the smaller radio receiver doesn't have one. So in order to bind the receiver, you will need to power it up for 5 seconds. Then unplug the battery. Plug it again for a second. Unplug it. Plug it again for another second. Unplug it. Plug it again. And on the 3rd time, the LED on the radio receiver is going to start flashing rapidly, indicating that the receiver is in binding mode. Now, in order to bind the radio receiver, head over to the system option, select general settings, and hit start. As you can see, now the radio receiver is bound. We can monitor the RSSI. Under the receiver option, we can monitor the link information, and we can switch the signal type between SBUS and PPM. You should note that even though the mini receiver and also the bigger receiver features UART ports, as far as I know, currently this option is not supported by Betaflight. So in case you would like to display the RSSI on the OSD, you will need to use the RSSI pad, which is located over here, and wire it to an RSSI pad on your flight controller in case it supports it. In addition, on its right side you can find 3 pads. This one is the ground, then the VCC in, and as far as I know, this radio receiver supports 5 volts, and over here you can find the output signal, which supports both SBUS and PPM. Now I'm going to remove the back cover of the radio controller in order to show its internal components and measure the output strength of the internal transmission module. The back cover is secured using 4 Phillips screws, but you should note that it is still connected to the main board, so you should be careful while removing it. Disconnecting the flat cable that connects the external module bay to the main board and the PH 2.0 plug that connects the battery to the main board will allow you to separate the back cover, and here you can see the internal components of the radio controller. These are pretty basic gimbals. The RF chip is located over here, and the antenna is connected using an IPX connector and secured using some glue. Now I've got my RF meter connected to the main board, and unfortunately I can't measure the output power properly, as I assume that the radio controller is using dynamic power and the measured output strength is really low. One more thing that unfortunately I won't be able to show you in this video is using the radio controller with flight simulators, as even after putting the radio controller in simulator mode, it just couldn't get recognized by my Mac computers. I hope PC computers are supported, but I wasn't able to test it out. As for my initial impression after using this radio controller, first of all, according to my range test, I can tell you that the radio system seems to be good. However, as for the radio controller itself, I can't fully recommend it as getting it for a racing drone. Maybe for UAVs and airplanes it's a good option, but for racing drones you probably would like to get a radio controller that supports OpenTX, as this is not a fully baked system. TBS Crossfire, for example, is not fully supported, and for this price range, which is cheap, you can get the TX16S. The cheaper version costs about $100 and fully supports the Crossfire system, which is one of the best long-range radio systems that you can currently get. In addition, the SIYI FT24 radio controller does not excel, at least in my opinion, in its ergonomics, and doesn't feature an internal charging module for the batteries. So overall, in my opinion, in case you are looking for a budget-friendly long-range system for your RC airplane, this is an option that you should consider. However, for racing drones, I think that there are currently better options in the market, and SIYI needs to come up with a better radio controller if they want to compete in the pretty tight market of drone racing. Anyway, that's going to be it for my initial review of the SIYI FT24 radio controller. The next video is going to be the range test, which, as you're about to see, is pretty impressive. And of course, if you have any questions about this radio controller, feel free to ask them in the comments section down below. Don't forget to leave a thumbs up if you like this video, and consider subscribing to my channel and hitting the notifications bell if you're not already subscribed. See you on my next videos, and goodbye.